Hello everyone. Let us understand what is a chemical reaction. In earlier standards, we have seen how compounds are formed by chemical combination of elements. Some of the scientists of 18th and 19th century carried out some fundamental experiments on chemical reactions. They proved from their experiments that during chemical reactions, composition of matter changes and that change remains permanent. On the contrary, during physical change, only the state of matter changes and this change is often temporary in nature. But before going to that, let us understand a bit about physical change and chemical change. To understand physical change and chemical change, let us identify physical and chemical changes from the phenomena given in the following table. Transformation of ice into water is a physical change because it involves change only in the physical state of water, from ice in the solid state to water in the liquid state. Water can be converted back into ice simply by freezing. Cooking of food is a chemical change because after cooking, the raw ingredients or the vegetables cannot be regained again. Ripening of fruit is a chemical change as once a fruit ripens, it cannot turn raw again. When milk turns into curd, a new substance is formed and that substance, that is curd, which cannot be changed back into milk. Therefore, it is a chemical change. Evaporation of water is a physical change. When water evaporates, it changes from the liquid state to the gas state, but it is still water. Remember, all changes of state are physical changes. Digestion of food in the stomach. Food is chemically changed in digestion when new, smaller substances are formed. So, digestion of food in the stomach is a chemical change. Size reduction of naphtha balls exposed to air. Naphthalene balls go under sublimation, hence it changes into vapor without changing into liquid. Staining of Shahabadi or Kadappa tile by lemon juice. It is a chemical change. The acid in the lemon juice reacts with the calcium carbonate contained in the stone and produces carbon dioxide. Breaking of a glass object on falling from a height. It is an example of physical change because if glass is broken, it still remains a glass. It didn't change to any other substance. Hence, with this some phenomena, we come to know about some examples of physical change and chemical change. Let us now summarize what is physical and what is chemical change. Difference between physical change and chemical change. Physical change is temporary and reversible. Chemical change is permanent and irreversible. In physical change, no new products are formed. In chemical change, new products are formed. Physical changes, generally energy is neither absorbed nor released during the change. But during chemical change, generally energy is either absorbed or evolved during the change. Example of physical changes: melting of ice, melting of wax. Example of chemical changes: change of milk into curd or burning of candle. A chemical reaction. When we call a particular process or phenomenon as a chemical change, some chemical reactions are taking place in the concerned matter. A chemical reaction is a process in which some substances undergo bond breaking, and are transformed into new substances by formation of new bonds. The substances taking part in chemical reaction are called reactants, whereas the substances formed as a result of a chemical reaction by formation of new bonds are called products. Chemical equations. The representation of a chemical reaction in a condensed form using chemical formulae is called as the chemical equation. Chemical reactions can be represented on paper with the help of chemical equations. Reaction between hydrogen gas and oxygen gas to form water can be written as 2H2 plus O2 gives 2H2O. Writing a chemical equation. The following table summarizes the symbols and terms used in chemical equation. Reactants and products. Reactants are written on the left hand side of the arrow. Products are written on the right side of the arrow. A single-headed arrow indicates that the reaction proceeds from left to right. It is a one-way reaction. A double-headed arrow indicates that the reaction can proceed in both directions.